Hello, in this video we will be covering flex steer. Flex steer can be used in a wide variety of applications, even when mechanical steering linkage is not desired. Flex steer allows for more design flexibility in operator stations and is very adaptable to fit different needs, as many steering input options are available, such as the joystick and e-wheel. Also, flex steer setups can be adapted for use with other steering solutions, such as quick steer, auto guidance, and multi-axis steer. When using an EHI, flex steer allows for the valve to be placed anywhere on the vehicle in steer-by-wire configurations, allowing for less cab noise and more flexibility in machine design. Flex steer is a Danfoss e-steering solution, which refers to the flexibility of the input device used in a system. Flex steer can be used with a standalone EHI, meaning that it is not connected with a traditional steering orbital. This allows the steering wheel to be replaced with an electric steering wheel, e-wheel, or joystick. Flex steer can also be used with an OSPE, or EHI and OSP, in which case the traditional steering wheel, joystick, and e-wheel could be used. Flex steer steering will require a vehicle speed sensor, a MMI input, and a wheel angle sensor. Once the hydraulics are installed and the wiring is completed, Service Tool can be used to set parameters to match the configuration and desired capabilities of the machine. For flex steer machines, the main parameter pages to be aware of are the peripherals and auxiliary aux config pages. In the peripherals config page, under the aux config section, the aux will need to be selected as present, and the aux type should be changed based on what kind of aux device is connected, joystick or mini steering wheel, e-wheel. The EH disengage method should be set to IMD if there is not a SASA in the system, and the hardware was chosen for hydraulic disengage. Under the GPS config section, GPS 1 and 2 should be set to not present unless auto guidance capability is desired. The aux config page is split up into 7 subsets. The mini steering and use thresholds control the velocity and angle at which the e-wheel must turn to be considered in use. For example, if the GPS function is being used and the e-wheel moves past one of the thresholds, then the GPS will be disengaged. Alternatively, if the e-wheel just gets bumped and only registers a slight movement, the GPS steering will continue to function. The aux mini wheel programs control the number of turns lock to lock. This can be used to enable quick steering. There are 5 aux programs for the electric steering wheel to determine how the number of turns lock to lock relates to the speed for each mode. The soft stop section is used to decrease flow to the cylinder when the wheels are close to the end stop to help prevent damage and jerk. Jerk happens in articulated vehicles because of the change in acceleration when steering. The anti-jerk parameters are used to decrease jerk in articulated vehicles by creating a smooth transition when changing steering direction. Anti-drift is corrected by adding flow when steering with the drift, so that as the steering wheel returns to neutral, it is turned less and therefore returns to the correct angle. The anti-drift parameters are used to control this correction between the difference in actual mini-wheel angle and the ideal angle. Flow limitation is used for open-loop joysticks to restrict flow to the cylinders at higher speeds. The open-loop joystick transfer function scales the joystick position to requested flow. The closed-loop joystick parameters limit the max wheel angle at desired speeds. The closed-loop gain sets the gain for different speeds. For more information on parameter settings, please refer to the PVED CLS user manual. Any combination of these profiles may be used to fit your application based on what will provide the best steering feel for a given machine. That is everything for this video. Thank you for watching.